In this video, I am going to be talking about these topics: functor and function object, and maintaining state in function object. Let me first focus on functor and function object. I am going to be using this editor and this skeleton code for my explanation. First, let me talk what is functor. Functor is a class which has overloaded a function call operator as a public member. So this makes it a class functor. When I say overloaded function call operator, it is this operator, if you are not aware of this. So this is the operator. This is called function call operator, and if we overload this operator and to make it a member of a class, that will convert the class to a functor. Let me begin with a regular function called sum to compute the summation of two parameters and return it. So let me have a code to call this function. So it will call this sum function and return display the return value into the output stream. Now I'm going to compile it and show you the output. Let me compile this code and run the code. It is displaying 45, which is a summation of 20 and 25. Now you can have a functor version of the same function, right? The purpose of having functor is to have a function logic in class version, so that we can use object of that class to execute that logic. So you can create a functor of this function. It's not necessary you use the same name. I'm going to use a different name with uppercase S, but you can also choose to use some different name, my sum or my function, or any name you want to choose, but you want to make sure that the name you choose is meaningful. It is easy to not get confused. Now I don't want to have any members, private members, public, and operator. The way you overload the function call operator is you need to have the syntax, type of the function should be same, return type int, and the operator you want to overload is this thing here, and followed by the other regular function things. For example, this is going to be the parameter list inside this parenthesis, and the logic is going to be in this space. So you put a parameter list in this place and logic in this place. That will make it the member complete, and we need to have semicolon at the end of the class definition. Now let me have a parameter list. I can just copy and paste the parameter list of this function, and I can copy and paste the logic. So now we have created a functor with the logic to receive two integer type data, compute the summation, and return the result. This is a class. To use this functor, you need to create an object of this functor. So I am giving the name sm, which is an object of this sum class. With this object, you can use this as you can have, once you create an object, you can consider this as the name of the function. For example, you can just call like this, right? So if I have this function, then I can call that the logic through the this object sm in this way. It's like calling the function, but you are using the name of the object. Let me show the output of this change version of the code. So now you can see 45 is displayed by calling the logic in the functor. So now here in this line, sum is functor and sm is the function object, right? So we call this is an object, and it actually implements the function. You can use this object to invoke the function, therefore we call this function object. I don't find many, I see many people referring this functor function object with the same name interchangeably, but calling this the class name as a function object does not make much sense to me. So I would prefer to call this sm as a function object and sum as a functor. Now it's also possible that you can you don't need to create an object. You can create a temporary object and pass it to the call at the same time when you create like this. You create an object, this will create an object and call this this way, right? With this it will execute the same logic, but it is a temporary object. There is no name of the object. It is created at this point, and once it is called, and the object gets destroyed. Let me show the output again one more time. So you can see 45 displayed in this place. Going back to the editor one more time, and you can use this if you have object, it's very convenient to pass this object to the function. You don't need to create a function pointer. If you pass this function to another function, you need to have function pointer. But if you want to pass this object or execute this logic from within the function, you can just pass the object in the way you would regularly pass the object of other classes, right? If I want to display this data within the function, I could do something like this: print function, and the type of the object I want to pass is sum. Let me pass by reference, and from within you can when you want to print, you also want to pass the data. So int a, int b, and from within the function you can execute a b, right? So, and you also want to print it. So this way you don't need to use this logic. You can call print function and pass object into it, and also let me see what is the problem here. You also need to pass the data 25. Now in this case as well, you can call the function, you can create an object and pass data 25, right? So this is the way you can call this print function. You pass the function object into another function and execute the logic from within that function. Let me run this and show you the output. There's a problem, cannot bind. The problem here is because this temporary object you can bind this temporary object to this, because we have pass by reference. So I need to remove this pass by reference. If I want to use this, I need to remove, because you cannot refer to the temporary object, right? So one more time. So now you can see the output 45 displayed by calling the invoking the function object from within another function. Now one more thing, let me comment this out for a moment. When you pass this, since this function object is not to make any changes, it's going to only display, grab the data, take the data and pass into the logic and display it. So if you are passing it by reference, then it is recommended you pass as a constant, right? But constant, when you pass object as a constant, it's really important that this constant object will invoke only because it is not able to make change, so it will require you to have a query. That means the function call operator that is overloaded, that must be query. Okay, for that either you can convert this operator as a query type, or you can have another version of this operator, query operator. So it will actually in this place, when you call in this place, it will actually call this function, this operator, and in this when you call from this place, it will call this operator. So but in this case, in this particular case, it doesn't make sense to have these two versions. Therefore I'm going to remove this for a moment. But what is this also demonstrates is that you can have overloaded version of this function call operator. Okay, it's not necessary that you have only one version of this function. For example, let me remove this, let me make change to this one. So I'm gonna be, if I pass, I can have a double type data, make it constant, and if it is double, let me multiply it. Okay, and I return the double type. So these are two versions, and if I call so the reason it was showing error is that C++ has a way of implicitly converting this integer to double, so it was actually found these two versions as ambiguity. So I tried to make it explicit integer type. And also, if I want to call another function, the double version of the function here, I can pass double type data 2.6, 3.9, something like this, right? So with this, it is actually calling two versions of this function call operator. Let me show you the output. So you can see the multiplication of 2.6, 3.9 happens to be 10.14. I hope it is correct, but definitely the summation of A and B is 45. Next topic I want to discuss is maintaining a state. This is one of the key features of functor or function object, in contrast to the regular function. So to discuss the state of the function object, let me remove. First I will briefly discuss here, using this same code, and I will remove this code and have a brand new or different code to explain that. So it's also possible that you can have a private. If you have private members, if you have private instance variables, then that instance variable, you can write the data into it, and that data actually amounts to the state of the object, function object. So when you say maintaining the state of the object, that means we have the attribute, the data members or member variables, and we have some data written into those variables. Okay, so I'm going to remove this entire thing and have a new exercise for this. So maintaining state of function object. Right, for this the example I'm going to use is weighted summation. Right, weighted summation means if I have numbers, let's say int x equals to 5. I think I should better use this main function. So I have int x equals to 5 and y equals to, let's say, 10. Maybe let me use this as a percentage. If I have midterm test percentage is 50 and final test So if I have midterm percentage 50, final test percentage 70, then weighted summation of this is going to be weighted average, or weighted summation of these two tests would be computed something like this. For example, if if a midterm is weighted 25% and the final test is weighted 75%, then you can do something like this: 0.25 times midterm plus 0.75 times final. So you have this weighted average, and yeah, you can use this for different purposes. So if you want to compute this kind of weightage, and if you want to have flexibility in having different weightage, for example, one time you want to compute the weighted average with 0.25 for midterm, 0.75 for final. Other time you want to compute weighted average with let's say 10 for midterm and 90 for final test. So if you want to have that flexibility, then function object, functor, can be helpful for that. So a function object I would like to create for this purpose would be functor. I would like to create for this purpose would be, let me give the name weighted summation, and I want to keep this 0.25, 0.75 as double numbers. Let's say weightage 1, weight 1 and weight 2 public, and I need to have function to set this weight, right? So I need to have a function to set this weight, and I would like to set, when we create an object in the constructor itself, b, and set it to w1, w2b. This is the constructor weight sum. Now when you want to set the weight in the beginning, when you create an object, you can do like this, and once object is created, if you want to update the weight or you want to change the weights, then you can have another function for setting it, set weight, something like this. Within the logic, maybe you can do something like this. You create a temporary object with a and b as parameters, and you copy that object to the current object. So this way you can create a, you can set, and we can have a overloaded version of the operator to compute the weighted average. So for the function, the logic of the functor should return, I would assume that it will return the double type value. It depends. You may want to have integer type or value or double type value, because if you want to see weighted test, if you want to see this weighted version of the percentage as a integer type, then you can choose the return type as integer. If it is double type, then choose as a double. In this case, I'm choosing this weighted average as integer type, whole number, but in the computation I want to use double type weight values, right? So for this I'm going to be returning double type and overload operator and parameters x and y, and x into y, and return w1 times x plus w2 times y. So this is the logic, and we want to have a semicolon at this point. So now we have this functor with the attributes to maintain the state of the object, constructor, a setter function to set the weights or to update the weights, and the overloaded function called operator. Let me have a code to use it. So first let me have midterm, wait for the midterm test 50%, no, it's 25.25 and 0.75. So this is the object we created, and this data actually determines the state of the object, and I want to display the outcome of the execution of the logic. Right, so it will display that, and I want to make change to the weights. Set weight to 0.2 20% and 80%. So now, so again let me explain it. I have this object created, object name ws, function object with weight values, weight for first item, weight for second item, 25%, 75%, and this is the invocation of that function to compute weighted average of 50% for the midterm test and 74% for the final test. And I want to change the weight to 20% and 80%, and then again I compute weighted average. So let me see the output of the execution of this code. So I'm going to be compile. I think there's a problem here. It's warning, so let me ignore this warning and execute the code instead. So you can see the weighted average, in the first case it was 65, and then in the next case it is 66, because in the second case more weightage is given to the final test, and the final test has higher marks, so it will obviously increase the weighted average to a little bit higher value. So this feature of function object to be able to maintain the state makes it more preferable to regular function in certain cases. Okay, finally I'm gonna use another example just to make it give you more clarity about the functor or function object. I want to use a class which many people actually use very regularly particularly in the college and university setting. This is probably the most widely used the class or the name of the class, which is student. So many people must be familiar with this, comfortable with this. So you might have used this student with different attributes, different member variables. It could be a static array, dynamic array. In this case, it's going to be dynamic array. So I can have a constructor, default, and I can have a custom constructor, validation, then copying the data. And this is shallow copying, this is a deep copying, if you are not familiar with these terms. So this process is called deep copying, and this process is called shallow copying. So I think this is the end. I think for this to use this function, we need to have the library here, string library, and yeah, I think that's it. So this is the student class. Let me have a code to use it. So ID 1001 and name Anirudh, and I need to have a function to display this data. So let me have a display function receiving waste-stream type object and using it to if ID, if data is valid, so otherwise invalid data. So this is the display function. I want to use that function to display the data here, and I want to pass right, let me first compile this, and then I will actually try to discuss this in the context of the function object. So now the data is displayed 1001 name Anirudh, so invoking. Now if you have overloaded version of the function call operator, in this case in this class, that will turn this into functor. Okay, if a function has, you may have a class with many functions, maybe 10-20 functions, member functions, but if it has only one function call operator, then that will it will be legal to call that class as a functor. So if I want to make this turn this student class to functor, I can add function call operator in this case to display the data, to do the same for the same purpose of having this display function operator. And then I want to have the same parameter here. It's always good, good practice to make this query as query by having constant keyword in this place. So I want to make this constant as well, and maybe try to copy the same logic. So now I have this overloaded version of the function call operator in this class to display the data. Okay, let me go back to this because I have not shown. Let me turn to the editor. Okay, I should have turned to the editor a bit earlier. So now I can have, in this case I am going to have another function, overloaded function call operator, to execute the same logic as this display function. Right, you can have a class with maybe 20-30 member functions in it. If this class has only one function call operator as its member, that will turn this class into a functor. So that is what that's the thing that you need to understand when you learn about functor or function object. So I'm going to overload this function to perform the same logic, to execute the same logic that is executed by this display function. Therefore I have void, I want to have void return type, and just to show you, just make sure, just focus your attention on this part. Okay, so I'm actually adding a query function. This function overloaded function called operator as query function. So there is one typo error, query stream, and copy the logic of this display function into this function called operator. So we have this operator. Now with this I can call this as a function. I can treat it as a function object. This is a function object. Then I can pass stdout. This should execute the logic of this overloaded function called operator. Okay. Right. So now let me switch to the output screen and show you the output. So now you can see the second version, function call operator displayed the same thing, same logic, and the display function displayed this output. Okay, the end of this video. Thank you for paying attention to it.